Okay, so here's the last problem. I did not do well on this test. I think I probably got like 92 or 93. Okay, and there you go. SB. So it was clear to me that that distance is SA, that distance is SA, that's a bit, that's SB, that's SB, and there's the bits going around the pulleys. So the total length was 2SA plus 2SB plus bits. Taking the derivative of the length is 0, derivative of all the little bits is 0. So we get that VA equals negative VB, which makes sense. When A goes to the left, B goes up. Okay, so we're given that acceleration of A is 10.5 to the left, which is, I'm taking as positive, meters per second squared. And I'm assuming that's constant, so that makes VA equal to initial velocity. It says starts at rest, so it's 0. So it's just 10.5 times t. And it makes the position at A equal to the initial distance from the pulley, which is not given, SA0, plus the initial velocity times time, which is 0. And so, and then 1/2 10.5 t squared. Okay, and they want to know how much things move from where they are now, and so we want the delta SA, so SA minus SA0 is 5.25 t squared. Okay, so everything for B is the opposite of that, right, because B and A are opposite of each other, so velocity of B is minus 10.5 t, and the position of B minus SB0 is minus 5.25 t squared. Okay, so there we go. We've figured everything. What do we need to know? Velocity of B at any time. That's right here. We've done that, so let me write it in. Minus 10.5 t, and just to be safe, I'm going to say going up. The position of B, so I'm assuming they mean how much it's moved, so that's delta SB is 0.25 t squared, and they want to do this at 5 seconds. So 25 times 5.25 is 131.25 meters. So delta SB at 5 is minus 131.3 meters. So minus 131.3 meters going up. And now VB relative to A at 5 seconds. So at 5 seconds, VA is 10.5 times 5, which is 52.5. That's going to the left. VB is minus 52.5, which means going up meters per second. And so finally, to get B relative to A, you have to know that velocity of B is the velocity of A plus velocity of B relative to A. And so that gives you 52.5 up equals 52.5 left plus VB relative to A. So solving for VB relative to A, putting that 52.5 on the other side, it's 52.5 up plus 52.5 going to the right, which is just 45 degrees to the left and right. And using Pythagorean's theorem, that comes out to 74.2. Okay. Okay, so thankfully I got this one right. The solution also said you could write this as 52.5I plus 52.5J meters per second. Either this answer or this answer is acceptable to me. So thankfully I at least got this one right.